Title of the first section is Review, Multiplication, Property of Exponents. In this section, we'll review the multiplication property of exponents, in which you add the exponents together. First question, x to the fifth times x to the eighth. Again, if you have the same base, the same variable, or same number, in this case we have x, would stay the same, and the exponents 5 and 8, we can add those together. So our final answer is x to the 13th. Next question, in parentheses, x squared, y squared. And second parentheses, x to the 6th power times y. Simplifying, we can combine the like bases, or the same variables. The x's, if we combine those, x to the 2nd power times x to the 6th power. We'll add the exponents, which would be x to the 8th power. And the y variable, y squared times y. The y, again, you can add the exponent of 1 if there's no exponent, and 2 plus 1 would give us 3. So our final answer, x to the 8th times y to the 3rd. Next question, x squared, and inside parentheses, x to the negative 5 power, y to the 2nd power. Simplifying again, we can combine the same variables, the x's. If we have x squared times x to the negative 5th, adding 2 plus a negative 5 would give us negative 3. And the y squared, there's only a single y, so y squared or y to the 2nd power would stay the same. Keep in mind, when you have negative exponents, you can continue to simplify. Rewriting this as a fraction, x to the negative 3rd power, we can rewrite that on the bottom or denominator of the fraction and changing the negative 3 to a positive 3. The y squared, since it's positive, will stay on top of the fraction or the numerator. So our final answer would be y squared over x to the 3rd power. And last question for the section, negative m squared times 4r to the 3rd power times 12r to the negative 4th power times 5m. Simplifying first, we can take the coefficients, the numbers in front of the variables, and multiply those together. If we multiply 4 times 12, that would be 48. And if we multiply 48 times 5, that would give us 240. There is a negative for the first variable, so that negative times 240 would give the coefficient or number negative 240. From there we can combine the variables. The m squared we can combine with the m, or m to the 1st power. M squared times m to the 1st. Adding exponents would be m to the 3rd power. And combining the r values, we have r to the 3rd power times r to the negative 4th power. Adding 3 plus a negative 4, that would be r to the negative 1st power. Continuing to simplify, again, if we have negative exponents, we can rewrite that using a fraction. Negative 240 would stay the same, since it does not have a negative exponent, and also m to the 3rd power would stay the same, since it does not have a negative exponent. R to the negative 1, if it has a negative exponent, we can rewrite that in the denominator using a positive 1 exponent. So our final answer would be negative 240 m to the 3rd divided by r to the 1st power. Title of the last section today is Scientific Notation. In this section, we'll simplify questions using scientific notation, which is a notation to represent large or small numbers. First question, in parentheses, is 2 times 10 to the third power times a second parentheses 3 times 10 to the second power. Scientific notation. This question has two problems or two numbers, each in scientific notation. Scientific notation, you have a number times 10 to some exponent. The number, though, has to be some number between 1 and 10. It can only be a single digit number. It could have decimals afterwards, but it can only be a single digit number and can be no larger than 10. Times 10 to some exponent. The exponent could be positive or negative. In this case, both exponents are positive. To simplify scientific notation, we can combine both of these together. The numbers in front, which are 2 and 3 in this case, we can multiply those. 2 times 3 would be 6, times 10 to the third and 10 to the second are two exponent numbers. They have the same base, which is 10, so 10 would stay the same. And the exponents, like we did in previous sections, we can add. 3 plus 2 would be 5th. So combining the two numbers into one single number using scientific notation, the answer would be 6 times 10 to the 5th power. And last question for the section. 8 times 10 to the negative 5th power times a second number, 7 times 10 to the negative 3rd power. And again, each of these numbers are in scientific notation, where you have a number less than 10 times 10 to some exponent. To combine two scientific notation numbers, we can multiply the numbers. 8 times 7, which would be 56, and times 10. The exponents, we can add negative 5 plus a negative 3, which would be negative 8. To simplify this one step further, again, scientific notation, the first number has to be less than 10. In this case, 56 is bigger than 10. So what we can do for scientific notation is if we have 56, the decimal point would be on the right of 56. We can move the decimal one spot to the left to make the new number 5.6. 56 again is bigger than 10, but by moving the decimal once to the left, we'll have 5.6, which is less than 10. Times 10 would stay the same. In scientific notation, when you move the decimal to the left one time, we'll take the exponent and we'll add 1 to that. So negative 8 plus 1 would be negative 7. So if you move the decimal to the left, you'll add that number. If in other questions you move it to the right, you'll be subtracting that number. Our final answer would be 5.6 times 10 to the negative 7th.